So a support question came in asking, can the ContinuuMini Surface be locked to a scale, say C harmonic minor, using the pitch table editor, the PTE? And after a little more questioning, locked to this person simply means not being able to trigger a wrong note once you select a given scale. Well, of course, you don't really select scales on the Continuum or the ContinuuMini, but you can set a scale as you would normally perceive it using the pitch table editor. However, this question raises a number of issues that we really need to look at. First, of course, is the Continuum and the ContinuuMini use a continuous surface. Although there are guides on the surface, there's templates on the ContinuuMini and the Continuum. The surface itself is continuous. On the ContinuuMini, it's basically a 2-octave, 2750 cent X-driven surface that has a resolution of better than a cent. And the Continuum has about 10 times better resolution than that. So if you press any arbitrary place on the surface and you take the template out of consideration, you really don't know what note that is. It's some pitch within maybe a cent on a ContinuuMini of some known pitch, but how do you know what it really is? And this person wants a specific scale to be locked in so that no matter where they touch the surface, only the notes of that specific scale will come out. Well, obviously, as a musician, you want to learn how to play scales. You don't want to have a crutch like this, but let's just take this as a Gedanken experiment, a thought exercise, and you can, in fact, do that on a ContinuuMini or a Continuum with the pitch table editor. So first off, if we press this position and we bring back the template on the ContinuuMini, we ask ourselves, all right, what note comes out if I press this particular spot on a ContinuuMini? Using the default tuning that's set and default scaling of the ContinuuMini. Well, the answer is still undefined because you have to ask yourself, what are your rounding settings that you have in place? If you have no rounding set and you have no initial rounding on, the note that will come out where you press the surface in this case will be the exact pitch that corresponds to that note on the ContinuuMini surface. And you can see here that's somewhere in the C sharp area, but it's a little flat of C sharp. If you pressed exactly in the middle of that template, assuming the ContinuuMini has been calibrated correctly and is using its default equal temperament setting, with rounding off, you'd be a little flat of C sharp if you play that note. Well, what if you turned rounding all the way up? You basically made this quantized. Well, in that case, if you played this note, a C sharp would come out. In fact, anywhere you played within the confines of the C sharp surface area of the template here, if you are totally rounded, totally quantized, a C sharp will come out. Of course, if you do that, you're kind of giving up the reason of having a ContinuuMini, the ability to bend and do portamentos and create vibrato, etc. So you can play and be quantized. But normally you don't want to do that. You want to impose some expression using your bend, your vibrato. And so your other option is to have either rounding totally off or perhaps some amount of rounding, but turn on initial rounding. What that will do in this case, if you press this place on the ContinuuMini surface, if you press and hold and don't move your finger, a C sharp will come out because you are initially rounding to whatever the closest note on your grid is, which in this case would be C sharp. In that case, you will play a C sharp, but then the minute you move your finger, you'll start implying a bend and you will be deviating from your true C sharp in that case. So pitch on a ContinuuMini or a Continuum, as you see here, is kind of relative. It's kind of based on where you press the surface in relation to the template if you are set in the default equal temperament mode, and it depends on what kind of rounding you have. And that initial rounding doesn't necessarily have to be where you press, there's other modes for rounding where you can go to your note that is closest in your template area when you lift the note coming off. So the note will snap to the expected frequency, expected note in that case. Well, you can look at all your rounding options. What we're going to talk about here is how you can actually rescale the surface of the Continuum or ContinuuMini to do something similar to what this person wants. So let's take the case here where we no longer want a 12-tone equal temperament scale. What we want is to reset the surface so that when I'm totally quantized, I'm playing some heptatonic scale, some 7-note scale. In this case, we'll make it a C harmonic minor scale, but it could be any 7-note scale of your choosing. It could be a Turkish makam or any other Arabic makam. It could be some kind of made-up 7-note scale that you come up with that has some kind of strange microtuning, up to you. Or it could be some traditional scale like a harmonic or melodic minor, in this case harmonic minor. So what we're going to do is use the pitch table editor, and we'll make this simple in our case here. We'll use scalar files to do this because it's very simple to do that. And you can see in this case the surface template no longer applies now. If I reset the surface and I set it into a quantized mode, when I run my finger up the surface, I should have the notes of the C harmonic minor scale playing. So I brought up the pitch table editor, which in its default state gives you the continuum representation of the 12-tet equal temperament scaling. Now you can use its features to change this scaling directly, but we're going to use scalar files, which is a simpler method of just imposing our desired rescaling. We'll start by reading in the harmonic minor scalar file. Now we're still going to be using equal temperament, so the notes we'll specify will be the harmonic minor scale, but still within the confines of equal temperament specification. And to do that, we'll use this scalar file that only has 7 elements, and after that the octave repeats, so there will only be 7 tones to the octave, and they'll be set to the cent representation that's required for harmonic minor scale. In the pitch table editor, we'll go in once that's up, and you'll have to have your Max MSP installed to run this. Select Import from the Edit menu, go in, select the scale you want, our harmonic minor, open that, and you'll see it automatically is starting to rescale the 7 notes that I need that falls outside the template that is the 12-note equal temperament per octave scale. What we'll do is we want to assign this so that the whole surface is using this. If we wanted to, we could assign it so that, say, from the midpoint of the surface up is our harmonic minor, but beneath that, we're still in the 12-tone equal temperament. That's one of the nice things about this tool. So what we'll do is say the starting location is 0 and the pitch offset we want is 0. So that will start our harmonic minor at the very bottom of the MIDI note scale, and then I can say paste, and that will, you can see all of a sudden everything is now offset to a larger grid than the template because we are now set 7 notes per octave. 1, 2, 3, 4, 5, 6, 7, and there's our octaves specifications. So from there, we go back to table. We then have to select the device, the eigenmatrix device we want to send this to. We'll select the custom grid, pitch grid 80. There are 8 of these that you can assign. So if you wanted to, you could have 8 different of these scales, and in the editor you can select which grid you want and it will automatically pop to that one. And then we'll go and select where we want to write this, and we want to write this to our ContinuuMini device. If we wanted to, we could select Continuum and rescale the surface of that in the same way. And now I'll just say send. And that'll take a bit, and it's writing now to the pitch grid on the ContinuuMini. Okay, that's done. At this point, we can exit the pitch table editor. We'll go into the Haken editor that I already had up, and you'll see it's already set to grid 80. Initial rounding is on. And what we'll do, just for the test case, is we'll set this to totally quantized. And now we'll bring up the video and play a little bit on the Continuum Mini, and you'll see what we've done here.